Hi everyone, this is number 4 from the 2019 FRQ exam no calculator section, and this is part B. So we have the cylindrical barrel with the diameter of 2 feet collecting rainwater. The water is draining out through a valve not shown at the bottom of the barrel. The rate of change of the height of the water in the barrel with respect to time is modeled by dH dt equals -1/10 square root of h, where h is measured in feet and t is in seconds, and they also give you the volume of a cylinder. Part B asks us, when the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing, and to explain the reasoning. So if you would like to pause to think about how to solve this, now would be a good time to do that. So one thing they tell us is that the height is h. So you know that h represents the height. I'm going to write that over here actually. And then that means that dH dt, which they give you want to think about what that represents. dH dt, yes, they give you that formula, but what does it mean? It's how the height is changing, or the rate of change of the height. Then part B is asking you how the rate of change of the height, which is dH dt, how that is changing, because we have the words increasing or decreasing. So the rate of change of height of the water with respect to time, that is dH dt, but they're asking you, is that rate of change increasing or decreasing? Or in other words, how is that rate of change changing? So if you were thinking about taking the derivative, that is correct, right? And just to recap, h is the height, dH dt is how the height is changing, or the rate of change of the height, and then the second derivative is going to be how that rate of change is changing. Is it increasing or decreasing? So I would think the trickiest part about this derivative is remembering that the independent variable is time, and the height is changing with respect to time. And because those variables do not match, we're going to need our implicit differentiation again. So the -1/10, we can bring that down. I'm going to also rewrite this as h to the 1/2, which that's something we know. So if we're taking that derivative, we would bring the 1/2 down, leave the h. 1/2 minus 1 is -1/2, and then we need the derivative of h, which is h prime, or dH dt. And I'm going to just write that over here for a second as a reminder for that implicit. The 1/2 moves down, the inside stays, 1/2 goes to -1/2, and the derivative of the inside is dH dt, or h prime. The derivative of h is not 1, again, because our independent variable is t. I did look ahead at the rubric, and they gave you a point if you were able to get this part, and then a second point if you remembered that you needed the derivative of h, which is dH dt. So that is 2 out of 3 already. And the last part, they are asking when the height of the water is 3 feet. So at that point, you would be plugging in. We have -1/10. We have 1/2. Let's go ahead and rewrite a little bit. Yeah, let me rewrite this. So h to the -1/2, I moved it to the bottom and made it a +1/2 and went back to the square root notation. But we're plugging in the 3 now. The height is 3. That comes from right here, when the height of the water is 3 feet. And then dH dt, think about that for a minute. Where are you going to get dH dt? dH dt was given to us. So dH dt, let me write that over here. dH dt is -1/10 square root of h. Yes. So right here, when I'm trying to evaluate dH dt, I'm going to use this and substitute it in, because that is equal to dH dt that was given in the question. So I have negative 1/10 square root of h. Again, the height they gave us was 3. So this is your answer. You could stop here if you want, but what you really need to recognize is that this is going to be a positive number. You can do whatever kind of simplifying you want, but basically the -1 and the -1 goes to positive. You can cancel these if you want, and then 2 times 10 times 10 is 200. All you need to recognize is that it's positive. So when you take the second derivative and we get that positive number, 1 over 200, or however you wanted to simplify it, the fact that the second derivative is positive tells us the rate of change of the height of the water with respect to time is increasing because it's positive. And so we have to write a sentence to summarize that. So the height was 3. dH dt is how the height is changing. The second derivative is going to be how the rate of change of the height is changing. So we would say when the height is 3 feet. Let me get my copy of this question just to see the wording here, because I'm copying from the question right now. When the height is 3 feet, the rate of change of the height of the water with respect to time is increasing. And then your justification is that second derivative is greater than 0, or you can write is positive. And jumping to the rubric, like I said, they gave you a point for that first part of the derivative, like I showed you. That I can put that right here too. So that was the first point. If you recognize that you also needed the derivative of h, that was your second point. And then the final point is the answer, which is right here. Because the second derivative is greater than 0, the rate of change of the height is increasing when the height of the water is 3 feet, and really leaning on the question to copy a lot of the question when you write that answer. And that is part B.